All right, well, this is going to be the little mini video on combination probability. So for this one, we're going to use an example with lifesavers. And we have 13 lifesavers total, 3 of which are green, 6 are orange, and 4 are red. And I've gone ahead and put numbers on each one of the lifesavers so we can, be sure to keep track of the fact that there are 13 different lifesavers that we're dealing with, okay? And the question we want to answer is, what is the probability of selecting 3 orange and 1 red lifesaver? The first thing we have to do is figure out how many ways we can get 4. Okay, so the total number of tries. So let's just kind of pick 4 from this group. Okay, so we could get these 4, or we could get these 4, or we could get these 4. And I'm not going to do that for very much longer. Down here at the bottom, I have recapped what we actually got when we did it the first 3 times, 1, 9, 13, 6, and so on. Now you'll see we didn't get any successes in terms of what we're looking for, and that's fine. We're not looking for successes, we're looking for the total number of combinations. Okay, so I'm not going to sit here and figure out that there's 715 of them. I just want you to remember that we can use the combination equation, which says that you have 13 objects and you're selecting 4 objects from there. So you put a 13 factorial on the top. The 4 goes right here in terms of what your R is, and then this value is basically the difference between the two. And you figure out the factorials and we get 715. So we don't have to go through and figure out that it's 715, but I did want to show you, the first 3 just to kind of get an idea of, why they're different. Okay, now we need to figure out how many different ways we can get a success. So again, for a recap, we've got 3 green, 6 orange, 4 red, and the success is that we actually select 3 orange and 1 red. So let's just start looking at what we could do to get a success. Well, we could choose these 4, and that would be a success. Or we could choose these 4, and that would be a success. Or we could choose these 4, and it would be a success. Again, I'm not going to go through this many more times, so let's just take a look at what we got the first 3 times. Okay, so we selected the oranges first, and then we tried to get the red, and we do need to use the formula because, like I said, I'm not going to sit here and figure them all out. So how do we actually use that formula when what we really care about is how many ways can we get 3 oranges and how many ways can we get 1 red. Now, what you'll notice is these 2 things are independent. Whether I pull out the 13 with the 8 and the 9 and the 6, it doesn't really matter. I could also get the 12 and it would still be a success. So what I really want to do is think about just the first set of numbers, the orange ones. I want to see how many different ways I can get this combination, and then how many different ways I can get these combinations, and then I can just multiply them together. Okay, so we're going to look at them separately. So the first thing we do is select 3 of these, or they could be these 3, or they could be these 3. And we're going to keep doing that, and ultimately what you'll see is we could use the formula down here, which is just that taking 3 objects from 6 total is going to end up with 20 different options. Okay, now if we go over to the other side, we could pick this one, we could pick this one, we could pick this one, so on and so on. And again, if we use the equation, basically it's just saying that if we have 4 items and we choose 1, we can use the factorials to come up with the fact that there's 4 different ways to choose them. Okay, now we have to put these back together. We get the same thing we got before, except for all the oranges are on one side and all the reds are on the other side. All these oranges over here and all the reds are over here. And then we bring them together. We want to know what is the number of ways we could actually have this. Well, it's going to be taking the 20 that have to do with the different ways we could select the oranges and multiplying it by the 4, which is the different ways that we can select the reds. So we end up with 80. Okay, so we get 80 different ways to get a success. We had 715 ways to get the total number of tries. So when we get ready to do the probability, it's just going to be 80 over 715, or 11.2%. So do you see why I keep saying just divide them up and think of them separately and then bring them back together again? It's just so that you can use the equation. Let's try one more example. So here I still have 13 lifesavers and we still have the same number of green, red, and orange. But this time I want to find the probability of getting 2 orange, 2 red, and 2 green. So the total number of ways to select the 6 is going to be a different number than we had last time. So we have 13 on the top and 6 on the bottom, and we have our 13 factorial here, a 6 factorial, and then the difference between the two. And if you do all the math, you get 1716. All right, so now what are the total number of ways to select a success? Now I think the easiest thing to do is just kind of picture that they're in their own little piles. And so you have a pile of 6 orange here, and you want 2 of them. You've got a pile of 4 reds and you want 2 of those. And you have a pile of 3 green and you want 2 of those. And what you'll notice is that the top has to add up to the number that we have up here. So 6, 4, and 3 is going to be 13. And the bottom, 2, 2, 2, has to add up to 6. So it's just a nice little way to check your math, make sure you're like not forgetting something. But it also makes sense, right? Because we have a total of 13, which is covered by the 3 different piles, and we need to select 6, which is covered by the total that we're going to select. So if you do all of that math, you get 270. So the probability that we're looking at is 270 over 1716, which is 0.157 or 15.7%. So there's another example. Hopefully that'll give you a better understanding of how they work, and even to like visualize the fact that, you know, we want 6 from this pile, right? And that's going to be the total number of ways. And when we're just calculating how to get a success, we want to go ahead and divide these up into their own little piles, and then we multiply everything together. Okay? So hopefully that was helpful. Thanks a lot.